Hey guys, Anish PyMaster Scholars here. So today we have another Q problem, and this time is going to be about the Fibonacci sequence. So we're basically going to be tasked with using a Q in order to generate the first K Fibonacci numbers, and writing a Python function to do so. So I have an example right here. So these are this sequence right here represents the first 20 Fibonacci numbers. And then if K was equal to 5, we would get the first 5 Fibonacci numbers, which are just these 5 numbers right here. So a Fibonacci sequence is basically where every element or every number in the sequence is basically equal to the sum of the two elements or the two numbers before it. And the sequence starts with 0 and 1. So the sequence starts with 0, and then to the right of 0 is 1. And then the third element will just be the sum of the previous two elements. So 1 is equal to the sum of 0 plus 1. 2 would be equal to the sum of 1 plus 1. 3 would be equal to the sum of 1 plus 2. 5 would be equal to the sum of 2 plus 3. So it's just like that. Basically, it just every element is equal to the sum of the previous two elements before it, and the sequence starts with 0 and 1. So then the first actual sum would equal just be 1, and then the second sum would be 1 plus 1, 2. So just add that two elements before it. So you should be able to see why a queue would be beneficial here. A queue, which is a first in first out data structure, it can just be used to it can be used to store the most previous two sums that we have found, or the most previous two elements um, in our sequence. And then every single time that a new element comes in, our queue should only store the most previous two element or the most previous two sums. So whenever a new element comes in, all we have to do is just sum the two elements that are in the queue, remove the first element in the queue, and then add in the new element or the new sum into the queue, because that's going to be the new sum in our sequence. And so if that doesn't make sense, I'll show you an example here. So let's say our queue, um, so first we have an empty queue, and we don't know what k is. K could be any number. It could be less than 2 or greater than 2. But we're obviously going to iterate k times using a for loop. And whenever our looping variable is less than 2, we basically just want to add the looping variable into our queue. The reason why is because when the looping variable is less than 2, that means that we don't even have two elements in our queue yet. And when we don't have two elements in our queue, then there's going to be no sum for us to actually calculate. So basically, if there's not two elements in the queue, that just means we're either on 0 or we're either on 1. So if our looping variable is on 0, we just want to add 0 to the queue, because that means that there's nothing in our series yet, or in our sequence yet, which means that 0 has to be our first element. If the looping variable is 1, then that means that only 0 is in our sequence, and we have to add 1 into our sequence. And then if the looping variable is 2 or greater, that means that there is already two elements in the sequence, and now you just calculate sums. So by the time that we're on by the time we're on looping variable 2, we should already be at the third element in the sequence, which means there should already be two elements in the queue by that time. So there should already be 0 and 1 in the queue. So basically, we have 0 and 1 in the queue. Now let's say that we needed to generate the first 5 Fibonacci numbers. So we're gonna have 0 and 1 in the queue, and then we have to add this one right here into our sequence now. And how do we do that? Well, this one will just be equal to the sum of the previous two terms, and the sum of the previous two terms of the previous two numbers in our sequence will just be the sum of whatever's in our queue. So 0 plus 1, which is 1. So uh, 1 will be added to the queue. And then what element do we actually keep in the queue? So we add 1 to the queue, and then we're only going to store 2 at a time, right? So we have to remove one element and then keep one element. And then what we're going to do is we're going to keep the last element in the queue before this element was added right here. So we're going to keep the 1 and then drop the 0. And the reason why is because, again, every number or every Fibonacci term, every term in the Fibonacci sequence is equal to the sum of the previous two numbers. And so in order to get the previous two numbers, we want to keep the last element in the queue, and then the new element that we add is going to be the second element in the queue. So now those two numbers are going to represent the previous two numbers of, and then an additional element that we add into the queue. So for example, 1 and 1 right here is going to represent the previous two numbers of 2. When we add 2 into the queue, 2 is going to be, so 2 is just going to be equal to the sum of 1 and 1, whatever's already in our queue. So we're going to add the sum of 1 and 1 into our queue, which is going to be a new element 2. And then what do we keep? We just want to keep the last element. We're going to drop the front of the queue and keep the last element of the queue. So now we have 1 and 2. 1 and 2 is going to represent the previous two numbers of this, our fifth element right here, our fifth element in the sequence, which is 3. So 3 is just going to be equal to the sum of the previous two terms, 1 and 2. That's in our queue right here, 1 and 2. So we're going to add 3. And then we're going to drop the 1, keep the last element in the queue, 2. So now 2 and 3 are going to represent the previous two numbers of this element right here that we're going to add, which would be 5, but we only need to generate the first 5 Fibonacci numbers. So if we want to implement it through code, so if that wasn't very clear, it should be more clear when we actually implement it through code. So we have a Fibonacci sequence. We want to generate the first k Fibonacci numbers, print that to the console. So what we're going to do is we're going to first make a queue. What is called that queue, the letter Q. And that's just equal to, for now, an empty deck. And then we're going to iterate k times, because we need k Fibonacci numbers for I in range. Okay. And then if I is less than 2, that means we know that we're still on the first or the second element in the sequence, which is either 0 or 1, depending on whatever I is equal to. So in that case, we'll just add whatever I is to the queue, because there's not even 2 elements in the queue yet in order to actually calculate a sum for the next element. Otherwise, if I is not equal to 2, that means if I is greater than 2, that means that there's already 2 elements in the queue, which means that the next element will just be the sum of those previous 2 elements. So in order to get the sum of the previous 2 elements, we're going to first remove both of the elements out of the queue. So we'll take out the first element from the queue, or the front element from the queue. We'll call that prev1, and then that's equal to the queue's current front element. So DAC at top left. Prev2 is equal to um, the next element in the queue, which is going to be the second previous element, or just the one that's directly before the next one that we're about to add. So basically the last element that we currently have in our sequence. So now when we get the previous 2 elements, we're going to add them. So our sum is just going to be equal to prev1 plus prev2. And then we want to, remember, drop prev1. We only want the most previous 2, or the most recent 2 sums, so that when we add another element, whatever's in the queue would represent the most previous terms for that element. So we want to drop prev1 and keep prev2. So we'll add prev2 back into the queue, and then we'll add the sum back into the queue because that's our new element. Prev1. And then so that's basically the logic. And then we have to print to the output, right? So every single time we add an element into the queue, we have to first of all print that element. So here when we append I, which is either 0 or 1, we also have to print that to the console. So we'll print I, and then we have to print it on the same line with a space after it. So end is equal to a space, or a quote with a space in it. And then same thing here. Whenever we add a sum, we have to remember generate the Fibonacci numbers to the console. So whenever we add the sum, we just print the sum. So now, so that's our method. We can see if we can test if it works or not by calling the sequence with a certain number. So we'll call that number k. Alright, so when we call the method with k, it should generate the first k Fibonacci numbers. What k will be equal to, we can let the user decide that. So k will just be equal to int, and then input whatever the user enters. So now we can test our code right here. So you see here, we prompt the user using the input method or the input function how many Fibonacci numbers you want printed. Whatever they enter, we just cast that to an integer. So let's say we want the first 5 Fibonacci numbers. So you see right here we have an error, so we can try to figure out what that is. Oh, it's a deck.pop left instead of the actual name of the deck. So q.pop left. So now we're going to test that code again. How many do you want printed? We'll say 5 again. And it prints the first 5, 0, 1, 1, 2, 3. Let's say we wanted 20 printed. So we'll run it again. 20. And then we'll see, yeah, does that output match what we have up here? These are the first 20 Fibonacci numbers. Yeah, it does. So that's how we know that our code works.